First off, how do you get it in the do you know like the air defenses they have? What are the air defenses they have? Casey, you don't have someone
Took an iron.
yeah, that's what you're supposed to do. You're supposed to like
What I done is, yes, we went high school.
depending on Casey.
You guys, only 3 of you have your work done. Is that acceptable ever? It's 3 problems. 3 problems that will probably take you 15 minutes. You can't give me 15 minutes? It takes me way longer to develop all this stuff. You know that? Way longer. Number 12. For number 12, they gave you the circumference and you had to find the diameter. So you still use C equals pi times diameter, but because you know the circumference, you plug in the circumference instead of the diameter, and then you solve for D. Did anyone attempt the last one? Those 3 people, I'm sorry, those 3 people that did their homework. Anyone attempt the last one? All right, any questions on the homework? Okay, get a worksheet off the back counter, please. Okay, so you also need your calculators, so make sure you have your calculators out. Alright, so today we're going to be talking about area of a circle. What did we talk about on Friday? We talked about circles. What specific part of circles? Danica? Circumference. Very good. And circumference is the distance around the circle. Okay, so that's like the perimeter of our circle. We use the formula circumference is equal pi times the diameter to find the circumference of a circle. So to find the area of a circle, we use the formula pi r squared. So what value do we use for pi?
3.1.
Very good. So pi, we use 3.14. What does r stand for? The radius. And what is the radius? No, what is, of any circle, what is the radius? Outside point to the center. Very good. It's the measurement from the center to any outside point on the circle. Okay? It doesn't just have to be like a horizontal line. It could be measured here. It could be measured here as well. Okay? So again, the radius is the measure from the center to an outside point on the circle. So the floor of a new butterfly conservatory will be a circle with an 18-foot radius. The material for the floor will cost $3.95 per square foot. About how much will the floor cost? So not only do we have to find the area, but we also have to find the cost of the floor. So first we have to find the area, so we know what to multiply by $3.95. And then we can find the cost of the floor. So the formula for area is pi r squared. For pi, we use 3.14, and our radius is 18. And then we square 18. So we'll look at your handheld calculators first. Okay, so if you've got a handheld calculator, 3.14, open your parentheses, 18, and then there is a squared button. If you're using this blue calculator, this type, it is 6 down, okay, or 3 up from the on button. And then close your parentheses. Okay, so yours should look just like this.
Okay, what I want you to do, on this one, I want you to do 18 first. So then I do 18 squared. Now, yep. Now times 3.14.
Because order of operations works better on that calculator if you do the squaring first and then multiply. Okay. You okay on those calculators? You guys okay? 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 Okay. All right, let's look at Desmos. So at Desmos 3.14, parentheses, 18, and then we square 18 and close our parentheses.
If you put PI, it just puts,
You could do pi, yeah. It's fine. But you get a way longer number if you use pi. So the area of our tile is 1,017 and 36 hundredths, correct? Everyone got that? Okay. So now that we know the area, now Now the measurement is feet. And anytime we have area, we need to make sure it's feet squared. Because what we've done is we've multiplied two measurements together. 18 feet by 18 feet. 18 times 18, and then feet times feet. So we get feet squared. So now that we know the area of the floor of our butterfly garden, or butterfly conservatory, is 1,017 and 3/600 feet square, we now need to calculate the cost. The cost is $33.95 per square foot. So what am I going to do? How am I going to calculate the total cost of the flooring? Yes, dear?
Multiply $3.95 by 1,017 and 3,600.
Very good. So we have 1,017 and 3/600 times the cost of the flooring, which is $3.95. $4,018.57. So when we actually calculated this out, we got 4,018 and 572 thousandths. Has anyone asked you for 572 thousandths? No. So remember, you could have this one here go out to the thousandth place. We cannot have this one here go out to the thousandth place because we're dealing with money. In American currency, we always round to the nearest hundred. Do you think this is something that flooring guys do all the time, or flooring people? Absolutely. We've done 3 different types of floors since we've been married. We put ceramic tile and laminate in our first house, and then in this house we did hardwood, carpet, and then we got this like new Cortex whatever in our basement because we just redid our basement. So every single time, my husband has to go through and calculate the whole house and calculate the area of the flooring so he knows how much flooring to buy and he knows how much it's going to cost us. Well, let me tell you a story. When we were building our house, all this flooring came to the house and I said, Allie, that looks like a lot of flooring. He goes, yeah, it's fine, it's calculated. He goes, we have a big area. We built a ranch. It's a big footprint. I said, remember, we're putting carpet in the kids' rooms and carpet in the playroom, so did you calculate that in? Yeah, absolutely. So the flooring's going in, the flooring's going in, the flooring's going in, and he gets to the kids' room. And he looks at this pile of flooring, and he looks at me, and I go, what's up? I think I overbought. Oh, really? You think you overbought? And he goes, yeah, I'm just going to do the kids' rooms in the flooring, too. I was like, what about the carpet? Oh, we'll just cancel the carpet. Good job, bud. So when we redid our basement, my husband comes upstairs, he goes, so I'm going to need you to help me measure the flooring. I said, okay, I'll do that. And so now, how many boxes of flooring do you think we have left over after we did the entire basement? We have 1 box left over. Because plan for mistakes, right? That's only 6 pieces of flooring in 1 box. So that's all we have left over. He goes, wow. I said, I said, honey, he teaches every year. He goes, oh, that's better than the 12 boxes we had left over after we did the kids' room. I said, yeah. Yeah. 12.
How many boxes did he buy?
Good morning. Hi, Mrs. Gordon. How are you? I can't remember how many he bought. I have no idea.
26?
No, God, so much more than that.
What?
Yeah. All right, so here's our next problem. Now, this is a real life problem as well. So my sister is a professor of musical theater down at University of West Florida, right? So one of the things that she has to do is she directs the plays and the musicals. They have one play every year and one musical every year. So one year they were doing like a senior showcase. They do that senior showcase every year. And she had 3 of her students singing the same song. They were doing like a trio or whatever, you know? So she calls me and she's like, I can't get the lighting right. And I said, what do you mean you can't get the lighting right? She's like, I don't know how to space the lighting out correctly. And I don't know what I'm doing wrong. So what we did was we did this exact same problem. We looked at the area of the spotlight and how far the spotlight needed to be up, how much area the spotlight was taking up, so that each person would have their own spotlight. And we had to do this exact problem. And I was laughing the entire time we're doing this problem because I said, this is literally a problem in my math book that I do with my kids. So if you want to be in tech at the high school for plays, or if you think that's something that you want to do with the rest of your life, you're still going to need math, right? Even though you think, oh, I'm going to be an actress, oh, I'm going to do tech, I don't need math. Literally, you need math. So this problem here, there's a spotlight above the center of the floor that covers a lighted area with a radius of 7 feet. What is the area covered by the spotlight? Go.
And my mom said, "Oh, Sarah, what is it? You go to school with them?" That's the reason why. That's the reason why.
You're getting your mind eye.
Hello? So I had to wait in the car for one second. The people stopped.
Oh, maybe we're doing that.
No, that was Robert. So I had to wait in the car for 4 minutes. Because I didn't want them to see it. It's up for two. Yeah, she's not really good at like eye contact. So that's why it's like, I'm gonna take a side or I'm gonna work.
Alright, what did we come up with?
153.86 feet squared.
Okay, so what do we use?
We use pi
Area
r
equals
squared.
pi 7 squared. Area equals pi r squared.
Pi r. Radius.
Yeah.
Okay, so area equals pi r squared. So 3.14 times 7 squared, right?
Yeah.
Right, and then what we get?
A equals 153.86 feet squared.
86.
I feel so smart.
So if my sister needed 3 spotlights, and she didn't want them to overlap, what would she then have to do?
Space them out. Or maybe put them up higher. She put them up higher. 130.
Okay, so if she's got 3 spotlights that she needs, 153 and 8600 times 3, she's got to make sure her stage is over 465 feet because she's going to need some space in between, right? So they don't overlap. So she needs to make sure, she's got to make sure that she's got that much space. Now, it depends on if she raises or if she lowers the spotlight, the radius can get smaller, right? So that's what we had to figure out when we did this math problem. Okay, so let me ask you a question.
Understanding 400 feet.
What if I gave you this? So we've got a circle that's got a diameter of 24 inches, and I want you to find the area.
That. So
Okay? Danica? Very good. 24 spans the entire circle. But we don't want this span of the entire circle. We only want the radius. So as Danica said, our radius is equal to the diameter divided by 2. So we'd have to take our diameter of 24, divide it into 2, to get the radius at 12. Okay. So if you're given the diameter, we need to make sure that we only use half of it. So then we would do what we typically do. Because 12 squared and 24 are very different. Would you agree with that? 12 squared is 144 versus 24. So those are things that are different. So we got to make sure that we are very careful about what we're doing here. We're squaring the number. We're not multiplying it times 2. So be very, very careful. The athletic department wants to paint the school's mascot logo on the gym locker room wall. They start by painting a solid blue circle on the wall. What is the maximum diameter of the logo if only 1 quart of blue paint is used? So, what information did they give you? Tucker? How much 1 quart of blue paint covers? So they give you what term? They give you the area. So if we're using area equals pi r squared, they're giving you the area, which is 78 and 5/10 feet squared. And they want to know the maximum diameter. Now this is something you have not seen yet. But we've got this coefficient. What do we need to do with this to get rid of it? We divide it because it's being multiplied. Okay? So we are going to divide 3 and 1400ths, or 3.14 on both sides. Divided by 3.14 cancels out. So we're left with r squared. And then 78 and 5/10 divided by 3.14, we get 25. What's different about this problem than any problem we've done all year? Very good. None of the problems we've done have r squared. Every problem we've done had the 2 in front of the r. So what this tells you is r is being squared. So that means r times r is equal to 25. What number times itself equals 25? 5. So r is equal to, but what if you have a number like 26? Or 58? No, it's not happening, right? So there is a button that we can use to help us find the value of r. Now, perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Well, those numbers, those are all perfect squares. So you could look at a multiplication chart and say, okay, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 10 times 10 is 100. 11 times 11 is 121, right? So you could look at that. But sometimes we're not given perfect squares. So what we can do, this is called finding the square root. And the button we're going to use is this. Now on your handheld, on your TI-30s, to get this, you push second, then x squared. Okay, so 25 second, I'm sorry, you gotta push second, then x squared, and this comes up, and then you push your 25, close your parentheses, and press enter. Okay, and then I'll give you 5. So again, this is your TI-30s. So you press second, x squared, 25, and then press enter. Did you find yours? Please.
I have something like that with an actual.
I haven't seen one of those in a while. Okay, Desmos. Okay. So you push your square root button, which is right here, and then 25, and it comes up. But wait a minute. Did we find the diameter? We didn't find the diameter. What did we find?
Circumference. Square root.
We found the radius. So all the way, if the radius is 5, all the way across is 10. Okay? So r is equal to 5. So that means diameter is equal to 10. All right, last problem. Ellie needs new grass and a circular pen for her chickens. What is the area of the pen? The information that they gave you was that the pen is 170, they used 176 feet of fence. So if they used 176 feet of fence, what measurement did they actually give you? Nope. Anna? They gave you the circumference. What do you need to find the area? What is the one measurement you need to find the area? You need the radius. If you have the circumference, can we find the radius? Yeah. So if we know the circumference is pi times diameter, we know the circumference is 176 feet. So we need to find the diameter. If we have the diameter, can we find the radius? If we know the radius, can we then calculate the area? Yeah. So we have the circumference. We need to find the diameter. Cancel. Calculate. non-terminating, non-repeating decimal, right? So what are we gonna round that to? 56, right? Is that okay for us to round? Yeah, it's okay for us to round. So our diameter is 56. So if we know our diameter is 56, how are we gonna calculate the radius?
By dividing that in half.
We're gonna divide it in half. We're gonna divide by, so we're gonna divide 56 by 2 to get our radius. Well, 50 divided by 2 is 25. 6 divided by 2 is 3. So 25 plus 3 is going to be 28. So if our radius is 28, how are we going to use that? Because it didn't ask for the radius. It asked for the area. So now I need to do another problem. Is this a real life math problem? Yeah, especially living out here. How many people even have chickens? Lots of people have chickens, right?
There's 20 chickens.
How do you know there's 20 chickens?
I
Oh.
I counted.
Now, if chickens need a certain amount of space, could we, if we knew that, could we calculate how many chickens we can fit in our pen? Yeah, because like, let's say each chicken needs 5 square feet. Could we then figure out how many chickens we can put in this pen? Yeah, absolutely. That's actually how they do fish in fish tanks. They know how many gallons or liters of water that a fish needs, and then you take the number of gallons of tank you have and divide that by the number of liters or gallons that the fish needs, and then that tells you how many fish you can put in a fish tank. Four problems? Can you handle it? You sure?
I felt really bad, so I started doing them immediately.
All right.